Welcome to Electrical Engineer's second Arduino tutorial. In this tutorial we will be covering digital inputs. To begin on the coding side of things, we will first have to define the pin that we will want to read. We can do this by writing #define. We will label our pin button pin, referring to it being a button, and we will set the button pin to pin 10. Pin 10 will be the pin we will be reading, so that is the pin that the button will be wired up to. Next, we will have to declare a variable, an integer, in which we will store the state of this pin. We can do that by writing integer int input state equals 0. We have to declare it to 0 in case there is an error in the system, and so not a null value is returned, causing a fatal error. In the void setup function, which runs once, we will have to declare the button pin as an input. We can do that by writing pin mode, the pin number, which is button pin, referring to pin number 10, and in all capitals input. Make sure that you write case sensitive, because Arduino C++ is case sensitive. In the void loop function, we will write the code that we would like to be executed repeatedly. In the void loop, we would like to check the value of the input pin, value of the button pin, which is the input, and it's a pin on pin 10, and we can do this by writing input state. So we will be setting input state, the integer variable, to the state of button pin, which we can do by reading it, by writing digital read the pin we want to read, which is button pin. Now the input state variable has the value of button pin stored in it. Since it's a digital read and digital signals can only be 0 or 1, input state is either 0 or 1. Next, since we want to do something with the result of this reading, we can do if input state is equal to 1, then we can make L.E.D turn on. To learn how to turn on an L.E.D, please check my previous tutorial. Make sure that when you are comparing a variable with a constant, you use a double equal sign, because if you only use a single equal sign, it will try to set the input state to 1, and it will cause an error in this declaration. Next, to execute the code when the input state is 0, in other words the button is not pressed, we will have to write another if statement or an else statement. An else statement is a statement which will be executed if the previous if statement has not been met, or the conditions of it have not been met. This is beneficial if we want to make sure that a function, something will 100% will be executed. However, in this case, we would not like anything to be executed if there is an error in the reading. So we will write if input state is equal to 0, make L.E.D turn off. Now this will run continuously over and over again, and due to it running a lot of multiple times a second, it will use quite a bit of power. So if you want to save some power, you can declare power save modes, which I will show you in a later tutorial, or you can just put a delay of say 100 milliseconds, And this is 0.1 second delay, and this will limit the amount of times the Arduino can run this code. This will limit the amount of power the Arduino will use. Therefore, for embedded projects, it will be more useful. I will explain to you how to wire up your circuit. Get a push button, and if you have a multimeter, measure out which pins or get connected when you press the button. Wire up one of the sides of 5 volts, and then the other side to pin 10. Make sure that you have a pull down resistor of roughly of a value of about 10k to ground from that pin. This is so that we can make sure that the pin value will not change state when it's at 0 volts. When a pin is not pulled down or made ground through a resistor, it is called a floating pin. This is a very complex theory of why this happens, and I will explain it in a later tutorial. For now, you just have to understand that you will require this resistor for your circuit to work properly. Next, wire up your LED as we did in tutorial number 1, because we will be using very similar code to make the LED turn on and to make the LED turn off. Okay, let's go over to our coding side, because we have to edit it slightly. This is the code we have done so far for detecting when a button is pressed. However, now that we have connected an LED, we also have to turn the LED on, and not just by a comment saying that we will have to do it, we actually have to do it. We can do that by writing #define, as I said in tutorial 1, LED pin, and as you can see, the LED is connected to pin 8. So, pin 8. Next, we will have to declare this as a output pin. Now, as I've mentioned and taught you how to do it, we can do digital write LED pin high, and then copy that over and you change the high to low. Now save your sketch and it will be ready for upload through this button if you actually have an Arduino connected. Since I do not, I will be using the digital simulator as I did in my previous tutorial. If you want, you can change the high and low, just so if the button is not pressed, that's when the LED is on. So, let's copy this code so I will be able to simulate it for you. Okay, so as you can see, the Arduino is powered up and it is on. Now, when I click the button, the LED should turn on. See? This is the circuit and we have created. This is a very basic circuit because you could just simply wire up the button to the LED to turn it on. However, learning how to do this will be very beneficial in the future when you have multiple buttons, and possibly it will be a keypad that you want to read. Thank you for watching and hope you enjoyed this tutorial.